Ionic channel. Please do remember, subscribe, like and share. Thank you. This video is focused on buffer solution explanation.
The pH of a reaction medium is one of the most important of the parameters that control the chemical changes in biological systems, industrial processes, and laboratory practice. For example, the pH of a reaction medium influences the growth of microorganisms and plants, activity of enzymes, permeability of cell membranes, characteristics of the electroplating process, and yield of industrial fermentation processes, such as wine or spirit production. Therefore, it is crucial for chemists to be able to measure, change, and control pH.
Buffer solution. A buffer solution is the solution that has ability to resist changes in pH upon addition of small amount of either acid or base. As what we know, when strong acid is added, the pH supposed decrease. While strong base is added, the pH supposed increase. But this solution has the ability to resist changes in pH upon addition of the small amount of strong acid or strong base. But their solution must contain acidic component or basic component, because for the acidic component can react with the added strong base or hydroxide ion, and then for the basic component it can react with the added strong acid, the hydronium ion. So solution for a buffer solution must contain a weak acid and its salt is conjugate base for acidic buffer solution, or a weak base and its salt is conjugate acid for the basic buffer solution. You can refer to this diagram. A is solution of dilute hydrochloric acid. This is unbuffered solution. That's why when addition of 1 molar of hydrochloric acid, the pH decreases drastically. Same for here, when the strong base sodium hydroxide is added, the pH increases drastically. But for solution C, is the mixture of 1 molar ethanol acid and 1 molar of sodium ethanoate. When strong acid is added, the changes of the pH just 0.02. Same for here, when the strong base is added, the changes of the pH also 0.02. So this one is buffered solution. So for a weak acid and its conjugate base, so by using the ethanoic acid and sodium ethanoate as the example. So the acidic component is ethanoic acid, and then for the basic component is the ethanol ion. Normally it's come from the salt sodium ethanoate. Same for this one, a weak base and its conjugate acid. Ammonia is the weak base. So the acidic component is ammonium, and then the basic component is ammonia. So the acidic component is come from the salt, okay, ammonium chloride. So this is the conjugate acid. Example 1, which of the following are buffer system? So based on what we discussed just now, for the buffer system must contain the weak acid and its conjugate salt, conjugate base, salt, or the weak base with its conjugate acid from the salt. So the first one, this one is the salt, and then this one is the weak acid. This one is the salt, and then this one is a strong acid. So this one is the salt, and this one is the weak base. Let's check the answer. So for 1A, this is the combination of salt and weak acid, so it's a buffer solution. And then B, this is salt and the strong acid, so this is not a buffer solution. And C, okay, this is the salt and this is the weak base, so this is a buffer solution. So always remember, for the buffer solution must contain the weak acid and its conjugate base, or weak base with its conjugate acid. Let's discuss what is acidic buffer solution. An acidic buffer solution can be prepared by mixing of a weak acid and its salt. So the salt is a conjugate base. We try to using the example acetic acid or ethanoic acid and sodium ethanoate. For a buffer solution at equilibrium, acid, this is the weak acid, will partially dissociate from the conjugate base and the H plus ion. Okay, the reactions that occur in the buffer solution included: first, ethanoic acid undergo partially dissociation and then form this ethanoate ion, while sodium ethanol undergo completely dissociation, form this ethanoate ion. There are high concentration of ethanoic acid over here because it's just partial dissociate, meaning that we are using one example. If there are 100 mole of ethanoic acid, maybe only 1 mole dissociate become the ethanoate ion, remain 99 mole of ethanoic acid over here. So here is the high concentration for the ethanoic acid. Okay. For this case, due to the salt sodium ethanol completely dissociate, that's why there's a high concentration of the ethanol ion CH3COO negative. The action of acidic buffer solution to control pH. There are two situations. The first situation is when a small amount of acid is added. The second situation is when a small amount of strong base is added. So when strong acid is added, it will react with base. So based on the equation just now, the base is the conjugate base, CH3COO negative. So it will react with the H plus and then form ethanoic acid. Due to the formation of ethanoic acid, the concentration of the H plus remain constant because when the strong acid is added, it reacts with the conjugate base and then form the weak acid ethanoic acid. So as a result, there will be only a small change in pH. At the same time, the concentration of acid, that's why the concentration of the ethanoate ion decrease and then form more ethanoic acid. So the concentration of ethanoic acid increase. Okay, when strong base is added, so it will react with the acid. Still remember just now? The weak acid partially dissociate. That's why the base will react with the ethanoic acid. So to form the conjugate base and water. Hence the strong base, the hydroxide ion consumed by react with the weak acid and then form the conjugate base. So now the concentration of the weak acid decrease and the concentration of the conjugate base increase. Basic buffer solution. Basic buffer solution can be prepared by mixing a weak base and its salt. The salt can form the conjugate acid. We are using the example ammonia as the weak base and the salt ammonium chloride, which can form the conjugate acid. So for this buffer solution at equilibrium, ammonia from base, okay, hydrolyzed partially hydrolyzed or partially ionized to form the ammonium ion and hydroxide ion. So for this reaction, it can represent with two equations. The first one is weak base, okay, undergo partially dissociation to form ammonium cation and hydroxide anion. And then another equation is the salt ammonium chloride completely dissociate to form the conjugate acid and the chloride ion. So the concentration of the ammonium is contribute from the ammonium chloride from the salt. So the concentration of ammonium is from the salt. And then since the ammonia is partially dissociation, that's why the concentration of ammonia is high as well. So meaning that when strong acid is added, okay, it will react with ammonia. When strong base is added, it will react with the conjugate acid ammonium. So let's check the explanation for this buffer solution. This is the explanation for action of basic buffer solution to control pH. When small amount of strong acid is added, it will react with ammonia. So the H plus the strong acid will be neutralized by the ammonia, which is a weak base, and then form ammonium, the conjugate acid. That's why the concentration of the H plus remain constant. So this is the equation. Ammonia react with the added strong acid, so it form ammonium. Meaning that the concentration of ammonia decrease because it react with the strong acid, and then the concentration of ammonium increase. Okay, the most important conclusion is only a small change in pH. Okay, when strong base is added, for this case, the hydroxide ion will be neutralized by the ammonium ion, the conjugate acid, to form ammonia. Okay, so this is the weak base. hence the hydroxide ion consumed. In this case, the ammonium ion, the concentration decreased because it react with the strong base, the hydroxide ion. And then the concentration of the weak base increased because form more ammonia. Okay, as a result, there will be only a small change in pH. Next is the calculation part. Okay, if you still remember previously we learned about the pH, pOH, Kw, pH plus pOH equal to 14. This one calculation is more focused on buffer solution. We are going to apply Henderson-Hasselbalch equation. Okay, so this is the equation for pH acidic buffer solution equal to pKa plus log conjugate base over weak acid. Is the Henderson-Hasselbalch equation for base. So we are going to apply pOH equal to pKb plus log conjugate acid over weak base. Okay, more discussion will be on next video. So please stay tuned. Stay tuned for next video. There are more calculation example and there will be have a tutorial discussion. That's all for this video. Please do remember, subscribe, like, and share. If you have any question, please don't hesitate to consult with your lecturers. Stay at home, stay safe. Bye.